So I want to do an example of percent error. When you're making measurements, you're not always going to be exact. You're not always going to nail it right on the head like you're supposed to. So basically percent error is just to figure out how much you goofed up when you're doing it. And we realize there's going to be some human error in there. Obviously we want to minimize our error, but it's good to understand how much we are away from where we're supposed to be. So I have some pretty basic numbers here to start. In this example, a student measured a distance to be 5 millimeters, but the actual measurement, the true measurement, the one they should have measured, was 6 millimeters. So the equation for percent error is actual minus measured over actual. And we want to multiply that number by 100 because it is a percentage. And there's something else that we want to do. We want to take the numerator and we want to put absolute value bars around it. I am not interested in whether I am 1 millimeter above, in this case I'm 1 millimeter off, 1 millimeter above or 1 millimeter below what the actual is. I'm just interested in how far away I am. So if you stop and think about a number line, if this is the actual 6 millimeters and I measured it to be 5 millimeters, when I subtract actual minus measured, I'm going to get a 6 minus 5 or positive 1. But if another group measured 7 millimeters, their actual being 6 minus measured, 6 minus 7 is going to be negative 1. But are they any better or worse than we were? No. They were 1 off, we were 1 off. It didn't matter which side of the 6 we were on. We were both equally wrong. We shouldn't have to worry about whether my numerator is negative or not. You're never going to have a negative percent error. Why? Because you take the absolute value. I am not interested in which side of the number line I'm on. I'm just interested how far away. I'm interested in a magnitude, how far away I am from this actual value. So in this example, let me plug in my numbers. Actual 6 millimeters minus the measured of 5 millimeters, again absolute value, divided by my actual of 6 millimeters times my 100. Now with absolute value here, treat those like parentheses. Let's do my subtraction, order of operations. I need to do my subtraction first before I divide. So 6 millimeters minus 5 millimeters, that's 1 millimeter. Again, if I had 7, it would be negative 1, but the absolute value would tell me to make it positive. Divided by my 6 millimeters times my 100. Notice what happens. Millimeters divided by millimeters will cancel out. So do I have a unit for my percent error? No, I do not. Okay, the units will cancel out. I'll just have a percentage there. So 1 divided by 6 times 100, and there's my answer.